I think we're good to go. Sorry guys, I had a few little tech issues. Mic not working, software up for renewal, a few other things. So just to kind of give you a bit of a rundown of why I decided to do this. Normally I'm sitting here by myself, just recording this on my own. But it's just, I thought I'll up the ante this time and try and do a live stream, and then I'll edit the videos. Yeah, I'm kind of recording on the side here as well, so that I can actually edit the video and put it up as a 1 hour. I'll try and cut it to 1 hour, but you know me, I can end up always talking a lot. So how does this stream gonna work? It's pretty much we're gonna go through each one of these questions. What I am gonna do is I'm mindful. I mean, this is the first time I'm trying to do this, where I'm trying to pre-record at the same time as live streaming. So when I am explaining the questions, if people could just remind me to either record or yeah, because what I'm going to do is I'm going to record each question, and then I'm going to just have a chat with you guys just to see if you guys are okay before actually moving on. All right, so what we'll do is we'll do each question. As usual, I'm going to tell you guys what you need to do for merit, achieve merit and excellence. I've got my answer schedule with me just so that we can try and kind of figure this out as we go. Yeah, and hey, welcome. By the way, I forgot to mention, I've got a couple of people just helping me out with a Discord server. So there is a link up right at the start there of this chat. If you have a look at the chat section, there is a Discord server, and like still kind of trying to figure out how that world works. But hey, it is something that we're trying. Cool, guys. So we're going to get straight into it, and I'm going to kind of remember to record these questions. So we're going to get started with question 1A here. Okay, so nice and easy. Well, never a nice thing to say at the start of the question one, but it is all right. So all we have got here is we've got two complex numbers, and we've got to actually try and figure out what the value of k is if st equals 21 minus I. So what we've got to do is we've actually got to multiply these two complex numbers here. So s and t, just kind of multiply it straight up. We're going to get 2 plus 3i multiplied by 3 plus ki. We know that the product of st equals to 21 minus I, so we can kind of say that this whole thing should equal 21 minus I. So just kind of dealing with your normal quadratic expansions there. So we've got 2 times 3, which is 6, and then 2 times ki, which is 2ki. Then we've got the bottom part of it that I've got to expand out. So I've got 3i times 3 is 9i. And then I've got 3i times ki squared, which is 3ki squared. Now all of this is equal to 21 minus I. I am going to kind of leave it as just like that. So just remember that I squared is equal to -1. So we're going to rewrite this whole thing as 6 plus 2ki plus 9i. What have you got? We've got 3ki squared. So this is going to end up looking like 3k times -1. So we've got 6 plus 2ki plus 9i minus 3k. So putting all my real values together. So my real values in this case is 6 and minus 3k. So I can put that together, 6 minus 3k. And my imaginary values, I'm going to just take the I out and just leave the terms inside. So I'm going to get 2k plus 9i. Now all of this is equal to 21 minus I. Now interestingly enough, k ends up being on both sides. So you could just go the real part equals to real, or the imaginary part equals the imaginary part. So in other words, you could actually say 6 minus 3k is equal to 21. Or you could actually do the 2k plus 9 equals -1, because remember that negative I is the same thing as saying -1. I'm going to go with the real values, so 6 minus 3k equals 21. So I got -3k equals 21, take away 6, negative 3k is 15, which then gives me k equals 15 over negative 3, or in this case, k is equal to negative 5. Now, let's say you did the other way, where you did 2k plus 9 equals negative 1. Then you're going to get 2k equals negative 1 minus 9, 2k equals negative 10, and pretty much same answer. So, but that should have been a 2. Yeah, so k equals to negative 5. So grades-wise, guys, you guys have to get the right solution. Either way you do it, you have to get the right solution for an achieved. Cool, so that's basically 1A. Let's see if this works. I'm going to stop recording. Any questions with 1A, guys? I'll kind of happy to answer questions before moving on to the next lot. Just chuck it up on the chat, otherwise we can move on to the next question. Cool, that's one person saying we're good, we can move on. Okay, so going on to question 1B. So with 1B, what we have got here is your classic discriminant question. What we have got here is has only one solution. So this kind of has to remember from level 2 when when we're dealing with discriminants, that when we have one solution, b squared minus 4ac is equal to 0. So all we have to do is we got to work out what our a, b, and c are. So you can kind of see that a is equal to 1, b equals to 4r, and c is equal to r. So once we have that, we literally just substitute it. So we've got b squared, which is 4r squared, minus 4 times a, which is 1, times c, which is r, and all of this has to equal to 0. So then expanding 4r squared is going to be 16r squared, minus 4r is equal to 0. And you can see a nice little quadratic here with 4r as a common factor. So we can get 4r minus 1 equals to 0. So once again, we've got a quadratic, which equals to 0. So you're going to get two solutions. So 4r equals to 0, or 4r minus 1 is equal to 0. So your first solution is r is equal to 0, and your second solution is 4r equals to 1, and r is equal to a quarter. So once again, guys, you need both of these answers to get an achieved for this question. Sweet. Any questions from you guys here, or are we happy to move on? Yeah, it's always I like the complex numbers, when we start with question like the A and B's, they're like real nice and simple. It's only when we get to the blooming E's that things start getting a bit messy. Not gonna lie, guys, so far I've got two little clips of question 1A and 1B, and it seems pretty comfortable doing this so far. Okay, so we're gonna go to question 1C. Cool. So with 1C, so what we've got with 1C is we've got a classic rearranging question with throwing a bit of square root symbols in it as well. The thing about square root symbols is that people always get kind of like muddled around with the square root symbols. Pretty much you can mess with it like I've seen people do this, like I just want to show you guys, like they try and kind of like do this, which is fine, all right? I mean, which is what we're gonna do. But what I mean is, like, I've seen people do this, sorry, there we go. Like when you say square, they actually take each individual element and square it. That's what I wanted to show you guys. But really, what we're gonna do is we're actually gonna do what I said originally, which is square both sides. So when we square both sides, and remember this part here, especially at the left-hand side, you do need to write 2 root x minus 5. And I would actually write that bracket again because people forget that there's a middle term, equals, and because you've got a square root with the 4x minus g, and you're squaring it, the square root just disappears, and you're left with just 4x minus g. Now the next thing is we've got to get rid of these brackets, right? So we're going to expand these brackets out. So first off, we've got 2 times 2, which is 4, and then root x times root x is just x, so we're going to get 4x. Minus 5 times 2 is 10, so that's going to become 10 root x. Then we have these two elements here, which is going to equal minus 10 root x plus 25, and this is now equal to 4x minus g. So far, so good. Putting them all together, so we're going to get 4x minus 20 root x plus 25 equals 4x minus g. Now, if you guys have a look at here, like, you know, your question is actually asking you to solve for x in terms of g. And we've got a root x in there. But the cool thing is we can actually get rid of this 4x and this 4x. Because when you bring it to the other side, you know, this becomes 4x minus 4x, blah, blah, it becomes 0. So we're going to leave this as negative 20 root x plus 25 equals negative g. And what am I going to do next is I'm going to, well, to be honest, you can kind of do whatever you want here because ideally you want to have x by itself. Whether we want to do it pretty, now let's do it ugly. So this ugly version is going to look like this, minus g minus 25. All I've done is taken the 25 to the right-hand side. Again, looking at all those negatives, you know what, you can just get rid of the negatives because if I divide this by -1, divide this by -1, divide this by -1, I'm going to end up with 20 root x equals g plus 25. Cool, still not done yet because we want to write x by itself. So once again, we've got to square the whole thing. Now, as for the g plus 25 squared, I'm not going to bother. I'm just going to leave it as it is. In fact, I'm not even going to do this yet. Let's actually get rid of the 21st just to make things easy for us. So I'm going to rewrite this as square root of x equals g plus 25 divided by 20. And I guess now I can actually square both sides because then it'll just become so much more easier because square root of x squared is just x. And as for the right-hand side, I'm going to get g plus 25 over 20, and the whole thing is squared. So grades-wise, we are looking at a merit for this final step. Correct squaring of both sides isn't achieved. So I'm guessing you are probably looking at either these two lines here to actually get an achieved for this question. But yeah, so it's not a bad merit question, just understanding when you need to square the square to get rid of the square root symbols, and then you should be pretty much good to go. All right, guys, I'll just stop recording that, but I'll answer your questions. Okay, hang on. Let's see. Do I need 6 A's to pass? Jake, not sure on which. Generally, 6 A's is pretty much solid. Like that's like a should guarantee an achieved, because if you get 6 achieved questions, you will probably get an A9, which should get you an achieved. Can you still expand and square the right side? Square the right side. Okay. Yug, can you tell me which line number you're talking about? Because like I always struggle with that. Like, can you tell me which line number? So if we take this as line number 1, 2, and so on. Vista, yeah, you can actually leave the answer like that. Would xg over 20 plus 0.8 plus 0.8, 25. Now 0.8, Stella, 0.8 would not work. I think it's 1.25. Because 25 divided by 20 is 1.25, if I'm correct. So 0.8 would not be acceptable. Not Beckham, you just missed about 3, man, so that's not too bad. Just the last one, g squared plus 125. No, Yug, it's not g squared plus 125 because remember, g plus 25, when you actually expand it, it will be g squared plus 50g plus 625. So unless you did something else. Yeah, one thing that I'll recommend you guys, and I know Stella, you try to do use the calculator for this, but what you can do is like, I mean, what you guys would have seen is like so far, I've not used the calculator at all for this paper. Complex numbers, generally speaking, you can actually do the whole paper without using a calculator. Theoretically, you should be able to do it without the calculator because the numbers they tend to give are quite straightforward. This one was a merit question, Beckham. Yeah, so the first two were achieved. I think they're fairly straightforward achieved questions. Yeah, so this would be an M5 McKees. Let me just check the schedule. 1T, 1 hour. Yeah, so if you get this one question right, you're going to get 5 points for this. And looking at last year's exam paper, what's the grade cut scores? I think you needed 9 to get achieved, which means who was asking before? Jake, you were asking me, do I need 6 A's to pass? Pretty much. Or you need 2 merit questions to pass, which will give you 10 points. So this is worth 5 points. All right, guys, so we're going to go to the next question. Let me know if you're okay. Are we still having a chat? Jake, for merit for this particular paper, you need 15 points. Generally, it's 15 points for merit, which means you need to get like 3 merit questions correct with each question. Like you can't get like, so what I mean by that is it's good that we're having this chat. Like, so I'll give you a bit of an example, right? So see how you got question 1, question 2, question 3. Let's say you get a merit here, here, here. That's worth 15 points, okay? Which means you're going to get overall a merit. But say you get an M here, an M here, an M here, and then here you only get like I don't know, 2 achieved questions. Then the points you're going to get is 6, 5, 3, which adds up to, what is it, 11, 14 points, which means you're still going to end up with an achieved. So even though you got 3 merit questions correct, you could still get an achieved depending on how that, which questions you get the merits in. Hope that makes sense, Jake. Cool. So we're going to move on, guys. I'm not going to lie, I'm actually enjoying this a lot more than sitting by myself and recording because this is a bit interactive and plus I can take my time. Sweet. All right, folks, so on to the next question. So what we've got here is a classic question, which is like basically getting rid of the denominator and writing in the most simplest form possible. So all we really have to do is just cross multiply in this case. There's nothing else we can do in this. All right. So we're going to take k plus ki. When I say cross multiply, it is basically just this, which I hate doing this upside down barbecue thing, but reality is it is hey, good to see you, Matt. Yeah, it's a good laugh. Hey, good laugh. Where did I go? Where did I go? Yeah, sorry, got distracted. Okay, so we got k plus ki, and we're gonna multiply with 1 plus I, and also in the denominator, we're gonna do 1 plus I. But really, we don't really care about the denominator because eventually it's gonna be 1 plus I anyway. But you know what? I'll do it both ways, just so that it kind of makes sense. And then we've got 2k over 1 plus I. Now on this side, it's going to get multiplied by 1 minus I and 1 minus I. So all we got to do is, yeah, we just got to cross multiply the bejesus out of it, and that's the long thing, right? It's like that's what's going to take such a long time, but it's all right. We kind of have to kind of do that anyway. So in my numerator, I've got k plus ki multiplied by 1 plus I plus 2k times 1 minus I, and the whole thing is now divided by 1 minus I and 1 plus I. So that's pretty much what I meant by the cross multiplication. Then we're going to have to expand all those brackets. So what do we got? We've got k and then ki. This is where you guys got to be a bit careful, right? Because it's so easy to make these mistakes. K and then you've got k times I, which is ki, and then I've got plus ki times 1 and ki times whatever the next thing is. So that's going to be ki again plus ki squared plus, this is a nice simple expansion of the quadratic. We've got 2k times 1, which is 2k, and then 2k times minus I, which is negative 2ki. All of that is divided. Again, we've got to kind of do this. Denominator, we've got to expand it out. So we've got 1 times 1 is 1, 1 times I is I, negative I times 1 is negative I, and then negative I times positive I is negative I squared. Okay, so let's get rid of all the I squareds. So we've got an I squared there, and we've got an I squared there. And at the same time, we're going to try and simplify as much as we can. So we've got k plus 2ki plus, the I squared changes to negative 1. So negative 1 times k is going to be negative k. And we've got plus 2k minus 2ki, and all of that is divided by 1. Plus I minus I is 0, minus I squared is equal to negative 1. Okay, so simplifying this now, let's just see what we need to get rid of. We've got k and negative k disappears, 2ki and negative 2ki disappears, and we are left with just 2k in the numerator, and in the denominator we're left with 2, which means our final answer ends up being just the k there. So grades wise, correct solution gets you a merit. And then correct expansion with common denominator, line 2. What do they mean by correct expansion with common denominator? Okay, so this is probably here that you're looking for and achieved. Yeah, so it's not a bad question, just like a lot of opportunities to make like little mistakes here and there. But yeah, that's pretty much a nice little merit question right there. All right, coming to you guys. Any questions with that one? Yeah, mapping it's kind of funny, right? Like when they put these kind of simplest possible form, they really mean by like that your final answer has to be pretty straightforward. And if you don't get that, you probably made a mistake somewhere and you probably need to go back and have a look. I've not seen vectors in calculus in a very long time. All right, guys, I think if we are good to go, we're about to kick off on our, yay, fun times, our first excellence questions. Somehow got k plus 2ki, k plus 2ki. I'm just trying to think where you made that error. Sweet Stella. Cool. Let's go to the next question. All right, guys, so we are going to the next question, which is an excellence question. And look, as I said to you guys before, like how we did with question D, it is simply just one of these very long questions. So it just means that you've got to actually substitute everything by yourself and then kind of expand it out and kind of work it out. That's why you got to try and do this question. So to kind of give you a bit of a kickstarter, what I might do is I might just do like the first part and give you guys a bit of time to actually have a go at it by yourself. And then I will actually do the whole question. So I guess the first thing to kind of realize is that we've actually been given what t is. T is a minus bi over a plus bi. And so what we've got to do is we've got to replace that with those those t's. We have to replace with that little fraction, and then you kind of need to expand it out and have a play around with it, and towards the end you will get to this answer. That's the beauty of this type of question, is when they ask you for a proof question, is it actually works out real nice to the end. And if you don't get that final proof, then you know you've done something wrong, so you can actually go back and have a check of where you made your mistakes. So what I've got here is 1 plus t squared. So I've got 1 plus a minus bi over a plus bi, and that whole thing is squared, and it's divided by a plus bi multiplied by 2. Because if you think about it, 1 plus t squared over 2t, that's what this is. And what we need to do right now is we need to expand as much of it as possible and simplify it and pretty much bring it to that format right there. All right, what I'm going to do is I'm going to pause this. You know what? I'm not going to pause it. I'm just going to let it roll because I can cut it later. I'm actually going to give you guys some time to try and do this question by yourself because, you know, yeah, it'll be fine for me to kind of like go through it, but I think it'll be really good if you guys have a go at this question because there are, like, even if you go to a particular point in this question, you can actually get achieved merit and excellence. So I'm going to take a 5-minute break. You guys have a go at this question, and then I will go through it. It would be nice if I put a clock up here somewhere. Can I get a clock? Oh, there we go. We got a clock right there. Okay, so it's 8:29 right now. I'm gonna come back at 8:35, and we'll actually go through it. Yeah, it definitely is Vista. I think it would be good if you guys actually try and go through with it. Can we rationalize t first? Tim, I'm trying to think how you would do that, Tim. You could do it that way, Tim. It might work, but I think it'll still create pretty much, I think you'll end up with the same answer anyway, so you should be okay. So have a go with it. I just realized I missed something here. That should be, sorry guys, if you kind of stuffed that up, that should be a minus bi over a plus bi. Yeah, thank you, rotation tricking. I picked it up just now as I was having a look at my working out. Hope you guys picked that up, guys. I made a slight mistake, which I've just made that change for the t in the denominator. Tim, it's not about how do I say it? It's not about hard. It's just about taking your time to work through one step at a time. All right. So the first thing you got to do is rationalize the numerator. Invicta, I know the feeling, mate. But trust me, this is actually one of the more easier like you can pretty much guaranteed 8 points in this question. Why? Because you guys have been given the answer. All you got to do is you got 3 hours and okay, you got an hour for this paper for complex numbers. It's just you got to remember a couple of strategies. Now I know you might not have done that before, but what we'll do is we'll actually go through this and you guys will see how easy it is to get this question, especially when it's a proof question and they say, if this is this, then prove this. All right, because trust me, there's only like so many ways they could actually ask this question for you guys. And it's a nice build up as well, because if you guys remember, if we go back to question D, it's pretty much exactly what we did in question D, just with the rationalization. That's all we're doing. How much space have I got? Yeah. Now, the frustrating thing about these questions is that sometimes you just don't have enough space, man. But let's try this. I might just do this recording again because I didn't realize it was still going. It's all right. You guys got a bit more time because my screen is just frozen and it's going to take me like a couple of minutes to try and figure out what the hell happened here. Um, I'm going to be honest with you guys. I know some of you guys are like talking about expanding. Um, Sometimes expanding it too early can actually be a problem as well. So you try and eliminate as many things as possible before you actually expand. Come on, man. No luck. Right, this is fun. There we go. We're back in business. Work, you stupid thing. Work. Maybe if I was a bit more nicer. Okay. 1, 3, 3, 3, 3, 3. Here we go. All right. Okay, guys. So question 1E, I'm just going to kind of go through again just what we needed to do. What we've got here is to go through this question again. We've got a t there, which we're going to replace those two t's with, and we've got to try and prove it. I'm going to try and write this as small as possible, but we're going to try and work this out. So we've got 1 a minus bi let's see, that whole thing, right? Stupid thing. We've got a plus bi and the whole thing squared divided by 2 times a minus bi and a plus bi. Okay, so the first step we want to do is we are going to actually sort out the numerator. Now, if you look at the numerator, in the numerator, we've got a plus bi in there, right? So that means we've got to have a plus bi here as well. But the thing is, it's going to be squared. So we're going to put that as a plus bi squared and a plus bi squared. So what we've really got here is a plus bi squared divided by a plus bi squared plus a minus bi squared divided by a plus bi squared. So that's the top line right there. Okay, now we've got that divided by, and we're going to put this as, what are we going to put this as? 2 a minus bi and a plus bi. Now notice, guys, I've not actually expanded anything yet. All right, I've kept everything as is. Now the next thing I can do is I can combine this two denominators as one. So my top part of the fraction is going to look like this: a plus bi squared plus a minus bi squared, and the whole thing is over a plus bi squared. Now this is just the top part of the numerator. Now that's divided by 2 times a minus bi and a plus bi. So that's one thing, right? Now the next thing we can do is, remember this: when you're dividing by something, it is the same thing as saying multiplying by its reciprocal, right? So if I was to do this, I'm going to continue this here so you guys can have a look here. So we've got a plus bi squared plus a minus bi squared divided by a plus bi squared, and that fraction, I'm going to rewrite it like this. All right, I'm going to rewrite it like this: 2 a minus bi over a plus bi. And I think this part is really important, because what we can now do is we can multiply it by the reciprocal of it. So I'm still, as you can see, I'm still not expanding anything. I'm still keeping everything as is. So I've got a plus bi squared plus a minus bi squared over a plus bi squared multiplied by, now flip the fraction over, so I've got a plus bi over 2 times a minus bi. So once I get that, I can get rid of one of my, the a plus bi, I can get rid of it, because that one goes away, and that just ends up being a 1 right there. So what I then have is, in my numerator, I've got a plus bi squared plus a minus bi squared, and the whole thing is divided by a plus bi multiplied by 2a minus bi. So I'm hoping you guys got where I got that from, because if you can kind of see what's happening here, then this question is just going to become a little bit easier. And also, by the way, if you got up to this part right here, I'm actually going to mark this paper as we go as well. If you get up to this part right here, this line, you've done it, that's going to end up being a merit. As for the achieved part is right here. If you get up to here, you actually get achieved straight away for that, getting up to that second line of that question. So now we are going to try and kind of bring this down, because remember, we've got to try and figure out how to go from here to this part here. It's terrible, but right there, that's what we're trying to prove to. So I'm going to start messing around with it a bit more here. Now we can actually start expanding the brackets. All right, so as you guys can see, I didn't expand at all until the very last moment when I can actually get rid of things and make things a little bit more easier. So here I've got a plus bi squared, so that's going to look like this, plus a minus bi times a minus bi, and the whole thing is divided by 2 times a plus bi and a minus bi. Because what you're going to notice now is things are going to start disappearing very quickly, because we've got to expand the quadratic in the top. We're going to get a squared plus abi plus abi plus b squared I squared. Then expand the next bracket. We're going to get a squared minus abi, and then we got minus abi again, plus b squared I squared. Just want to check that if I've done it all right. 2abi, yep, that's all good. And that whole thing is now divided by 2. A plus bi times a minus bi, that's just going to be a squared minus abi plus abi minus b squared I squared. Now I need to go and get rid of all my I squareds. So I've got an I squared there, I've got an I squared there. Putting it together, I've got a squared plus 2abi minus b squared, because I squared is -1, plus a squared minus 2abi, and then we've got minus b squared again. And the whole thing is divided by 2 a squared and then I squared. Oh, we've got another I squared here. So that abi and abi is going to disappear, and we're going to get plus b squared. Okay, now if we look at the top, the numerator, we've got 2a squared, because these two things cancel out, minus 2b squared over 2a squared plus b squared. Take the 2 out as a common factor. We've got a squared minus b squared over 2 times a squared plus b squared. And as you guys can see, we end up with our proof, which is a squared minus b squared and a squared plus b squared. So now if you were to try and expand somewhere in this area, you are going to, you're going to end up getting it very, very messy. But the thing is with these types of questions is that you do not want to expand way too early at all, that you literally just try and keep it together as much as possible until the very end. So yeah, right at the bottom, that ends up with excellence for that question there, for the proof question. All right, guys, I'm going to go back to the comments and just kind of go through them. Give me a second. 1, 2, 3, 4, 5, 6. Yeah, that's fine. I don't even know where I got up to last. It's the old surface. Speaking of the old surface, I'm hoping that I'm going to get a new surface, but we'll see. Stanley, you're welcome. That's not a problem. Yeah, thanks, Stella. It's all right. Mechanics. Yeah, confusion. I think that's the key thing, right? Like you don't want to try and expand it too early. I hear you, Invicta, but it's like I said, it's one of those questions that just gives you 8 points. Rotation tricking. This document is available. Oh, damn, I didn't actually put that in here. Okay, give me a second, man. Rotation, I'll get you this document because it gets updated live so that you can actually, instead of taking a screenshot, you just go to that the OneNote that I have. Don't write exams. Most topics of, yeah, talk about off topic. I'll never have time, Invicta. I don't even have time to do my own kind of things. I know someone did mention talking about gaming, and I was started playing again, but like just kind of get carried away with things. Give me a second. I'll go find that link for rotation, and then we'll get on to the next lot of questions. Jeez, it's a long. Okay, hang on. Where is this link? Sorry, guys, just trying to find that link so that you guys can actually see this notebook in action. Control copy, there we go. Yeah, I was going to ask JB, like, should we just try and get differentiation out of the way tomorrow? Tim, you're talking about here. The reason we did that was because it was, remember, it's actually 1, and we want to try and have the denominator same. So we're just going to rewrite 1 as a plus bi squared over a plus bi squared. Because it's like, think about it like this. You know how if you have something like 1 plus x over 3, then you would write this as 3 over 3. So this becomes 3 over 3 plus x over 3. So yeah, that's pretty much why we were trying to do that, that a plus bi squared over a plus bi squared. Same kind of idea. Cool, guys. Are we ready to go on to the next question? Question number 2, by the way. Let's get rid of the time. Why is it still there? Okay, let's go to the next slot. All right, guys, so we are going off to question number 2 here. So question number 2, what we've got is, we've got, given that x minus 2 is a factor, we've got to try and find the value of q. So remember that if x minus 2 is a factor, then we can say that f of 2 is equal to 0. So all you got to do is substitute wherever x is equal to 2 and put this whole equation equal to 0 and figure out what q is. So we're going to do that as 2 to the power of 3 plus q, 2 squared minus 17 times 2 minus 10, and all of that is equal to 0. So we've got 18. No, we don't have 18. We've got 16 plus 4q minus 34 minus 10 equals to 0. So we've got 4q plus 16 minus 44 equals to 0. And I cannot believe my head is just hurting at the moment, and we got 4q minus 28 equals to 0. Rearrange it. So we've got 4q equals to positive 28, and q is equal to 28 over 4, which gives us 7. So, achieved. Question to kind of kick it off with. So yeah, so that's pretty much it for this question. There's nothing really special about this question. Straightforward, substitute the x value and then figure out what q is. Any questions, guys, or can we move on to the next one? Yep, that's enough silence for me to say move on. Okay, so going on to the next question. Next question, what we have is find all possible values. All right, nice little clue that they give you guys by saying that it's all possible values, um, which means we can kind of realize that it's not just going to have one answer. So what we've got here is a modulus is equal to 13. So all we really have to do is we can actually rewrite this as, what can we say? So we can actually say modulus is 13. So we can say 5 squared plus 3k squared equals 13 squared. All right, that's pretty much it. That's what modulus is, right? So we can actually say this is 25 plus 9k squared equals 169, and then rearrange it. So 9k squared is 169, take away 25. 9k squared is 144, and then k squared equals 144 divided by 9. K squared equals 16. And of course, don't forget, guys, you have to put down k is equal to plus or minus 4, because square root of 16 equals plus or minus 4. So that's pretty much what we're looking at for that. And once again, grades wise, we are looking at an achieved. That's basically it for achieved, for this question anyway. Why'd you square both sides? Okay, so think about it like this, all right? When we have a complex number, x plus iy, so the complex number x plus iy looks like this. So that's x right there, y is right there, right? So this is what the complex number looks like. Now you can see that this right here is the modulus, which is r. That's r right there. So if you think about it like this, you've got x and y. So we can rewrite this as x squared plus y squared equals r squared. Now in our question right now, that's 5 right there. That's 3k. And then the r part is 13. So that's why we rewrite this as 5 squared plus 3k squared equals 13 squared. Kind of similar to equation of a circle, Marquise, because it is looking at an x, it's a relative of it, but yeah, we kind of call it the modulus more than, but similar ideas, yeah. I tend to use the Pythagoras theorem because you go, right, the x is the bottom part of the triangle, y is the other length, and then r is the hypotenuse. Pretty much the same kind of ideas. No. You can't do that in Victor because remember, I'm gonna kind of zoom in here. There's these two lines here that you got to consider. All right, it's not just 5 plus 3ki equals to positive 13. It's actually the modulus. That's what the two straight lines look like, the one that I've highlighted in pink. That's what it means. It means that it's a modulus. So you can't just do what you just said in the comments there. Any other questions, guys, before we move on? Why does it become plus 3k instead of minus 3k? Because rotation, because it actually says plus 3ki, that's why we're going to the top and not the bottom. Would I squared not make it? No. We're not going to look at the I squared. We only look at, if you look at what I've done here, see, the imaginary axis is the highlighted in green. So when it's in the imaginary axis, we don't actually put I there. We just know that it's in the imaginary axis. So for example, if I say something like 3 plus 4i, then I know that 3 is somewhere here and 4 is here, but this is in the imaginary axis, not the y-axis, but the imaginary axis. Think about it like that. Then 3 and 4 ends up being here, and the modulus is the length of this black line, which is going to be 3 squared, 4 squared, and like, because you know how it's 3 and 4? So we're going to get 3 squared plus 4 squared, which equals to 25, and then square root of 25 is 5. But that means basically the 5 is the distance from the center to that edge of that complex number. So we don't really deal with the I at all. We just look at the coefficient of I and coefficient of the real value. Cool, guys. We're going to move on to the next question. Yeah, no, that's all good, man. Okay, so going to question C, which happens to be one of my favorite questions, because this question, I don't know why, it just comes every year. And I have not seen a year where this question has not come, and I'm hoping that the trend continues. Cool. So here we go. What we've got here is we are told that one of the solutions is Z is 3 plus I, blah, blah, blah. We've got to try and figure out the other solutions and the value of B. So the first thing I'm going to kind of talk to you guys about here is this. Because it's complex, right? We know that if Z is 3 plus I is one solution, then 3 minus I is another solution. All right, so this is just one of those things that you kind of pick up with complex numbers, which means we can actually rewrite this whole equation now. And I guess there's so many ways of doing this. You can actually do this straight in the calculator and figure out what B is. It's a little bit trickier, I guess, for this question. But again, I'll show you guys some of the things. So first thing to realize is we've got a Z cubed here. All right, that's the first thing you need to realize. Now, our first solution, which is 3 plus I could rewrite it like this. So I could write Z minus 3 plus I. So that's my first kind of like my bracket. Because you know, Z, when you have a cubic, you're going to have like 3 brackets. That's my first bracket. My second bracket is going to be Z minus 3 minus I. And then finally, my third bracket is going to be, I'm going to call it AZ plus B. All right, these are the 3 brackets. Maybe I shouldn't use B. Hang on. Let's try something else. What's another letter I can work with? P and Q. Let's go with P and Q because we got a B in there and I don't want to kind of mess it up. So once we get that, what we do know is we know that Z multiplied by Z multiplied by PZ is going to equal to 2Z cubed. All right, so that's the first thing we're going to do. Z times PZ equals 2Z cubed. So here on this side, we've got PZ cubed equals 2Z cubed. So we can say P is equal to 2. So in other words, I figured out my first part of this bracket, which is 2Z. Then my second thing is to try and figure out that value of Q. Now to do that, I've got negative 3 plus I multiplied by negative 3 minus I multiplied by positive Q, which all equals to minus 30. Yep, Tim, you can actually do that. That is a completely fine, that's one way you could do it as well. That's not a problem. As I said, there's like quite a few ways you can do this. So if you guys have a look at some of my previous exam questions, I would have done it slightly differently as well. So have a look through that as well if you can. So here I've got negative 3 plus I multiplied by negative 3 minus I multiplied by Q equals to minus 30. So the 2 negatives disappear. I've got 3 times 3, which is 9. I'm just going to leave that Q out there for now. And I'm going to do this part here first. So I've got 9 minus 3i plus 3i. It's not going to matter. and I've got minus I squared. Q equals minus 30. Now I squared is equal to -1, so I'm going to get 10Q equals -30, and Q is equal to -3. So my final factor that I have is 2z minus 3. Cool. So if we have a look at this, just going to kind of put them all together now. And I think I've actually made this a bit longer for you guys, but that's all right. So we found our final factor, which is 2z minus 3, which means we also found our final solution, because our solutions are going to be 3 plus I, 3 minus I, and when you've got 2z minus 3, rearrange that, you're going to get z is equal to 3 over 2. So 3 over 2. So these are our three solutions. But we still need to figure out what the value of b is. And that's right there. So as Tim was kind of mentioning it, so we could actually substitute 3 plus I. And for this, I am going to use the graphics calculator to kind of show you guys how to do this as well. So what I'm going to do is I'm going to substitute z, 3 plus I as z. So I'm going to get 2, 3 plus I to the power of 3 minus 15 times 3 plus I squared plus b times 3 plus I minus 30 is equal to 0. So what I'm going to do is I'm only going to do this part in the calculator, guys. So this part and this part in the calculator. All right, now if you are a bit brave and you want to use the solver function in your calculator, you could actually do that as well. But yeah, I mean, we can kind of do it multiple ways, but I'll show you guys this method first. Okay, so what I'm going to do is I'm going to use the answer function as a bit of a shortcut here. So I'm going to put down 3 plus, my I button is under here, shift 0, that's my 3 plus I. Cool, I've got that. So right now, anytime I click on answer, it's going to lock in as 3 plus I. So what I'm going to do is I'm going to go 2 multiplied by answer to the power of 3 minus, what do we got, 15 is it? Yep, 15 times answer squared, and then minus 30. So what this gives me is -114 minus 38i. So all I've done is I've calculated whatever this yellow part here is. The yellow part is equal to minus 114 minus 38i plus b times 3 plus I is equal to 0. So I'm going to rearrange it. So I've got b 3 plus I equals 114 plus 38i, and then b is equal to 114 plus 38i divided by 3 plus I. So for that, I'm just going to be a bit lazy and just use the calculator here. So that divided by 3 plus I. Just checking the answers, guys. Yep, so b is equal to 38. So grades wise, we're looking at one, other two solutions found and b found. So you need this and you need these two things to get a merit. For an achieved is finding this, I'm going to put this, or one of this for an achieved. Bit of an annoyingly long question, but it is what it is. So any questions with that, guys? Sorry for the link, but that's what I found. Invicta, yeah, the absolute value is, it's how do you say it? In math, sometimes we tend to use like similar symbols for a couple of different things. Lucy, yes, this live stream will get uploaded, and I'll also edit the video and put a 1 hour short video as well, so it should be there. Yeah, Yug, you could have done that as well. That's another possibility. So this question has like lots of ways you can solve this. So it's really up to you on what you find comfortable in. And I'm just trying to showcase, like, I think the last year when I did this paper, like last time I did this type of question, I did this slightly different. Yeah, I could actually show you guys how to do that in the calculator as well. So if you want to, you can do the last part in the whole thing in the calculator. So you can just go to solver and just put the whole thing in. So you've got 2 multiplied, I'm going to try and do it. Let's see if this actually works. 3 plus I. Tim has asked me to do this, so sorry, Tim. Actually, that's not a bad idea as well. Yeah, rotation, that's actually a pretty, that does work. Sorry, man. I think I just made this a bit longer for everybody. You are absolutely right. That should also work as well. I will actually put both of them working out for you guys so you guys can see what it looks like. Let's get through this ugly looking thing first. 3i squared plus alpha b. Where's alpha b? B times 3 plus I minus 30. And that whole thing is equal to 0. Of course, I made a mistake somewhere. Where did I make the mistake? 2 times 3 plus I. Nope, my one's not working. If it's working for you guys, great. Yeah, I don't know why it's not working for mine. Rotation, you could have done that as well. 6ZQ 10PZ. I'm not. See, the other way that I was thinking that you guys could do was instead of substituting 3 plus I, you could have actually substituted 1.5. Because remember, 1.5 was one of our solutions. So we could have actually just, instead of putting it as that, we could have actually gone 2 times 1.5 cubed minus 15 times 1.5 squared plus 1.5b minus 30 equals 0. That's another way you could do it as well, which should still give you guys the same answer as well. Yeah, so it's a good point there, rotation, if that's what you meant by. But yeah, I was just saying that like you could potentially put any one of these 3 solutions in here, put it equal to 0, and actually figure it out. So we didn't need to put the 3 plus I. We could have also done the 1.5 and actually try and solve that as well. Okay, so we're going to go on to the next question, guys. Yes, Invicta, what's up, man? No, it's fine, rotation. As long as you're getting it, that's all that matters, right? One 1.5 is from here. Notice how we actually worked out one of the factors, how it was 2z minus 3. And then what we have to do is we kind of put that equal to 0 and rearrange it to end up getting z equals to 3 over 2, or 1.5. Hope that makes sense, confusion. All good? Okay, so here we have an annoying question. All right, and the reason I call this an annoying question, I'm actually going to record this part. Cool. So with question D, it is a bit of an annoying question, as I said before. Now, the long method can actually be quite tedious, where you're going to have to like put u over v, right? Like you're trying to find the argument of u over v. So you got u over v equals p plus pi divided by negative q plus qi. And I can tell you this right now, this is going to be like a total pain to try and rationalize the denominator. But remember this, when you have argument of u over v, and I'm talking about this is one of the rules you guys will have learnt. This is the same thing as saying argument of u minus argument of v. All right, so it is pretty much that's the hint right there. Like this method here, I'm going to put this. If you were to put go with the green box and kind of like go in that direction, you're going to end up wasting about a good 5, 6, 7 minutes. All right, while the yellow method here, you're probably going to be done with this question in about 2 minutes. Why? Let's have a look at this. U is equal to P plus PI. Now, if I was to draw that real quickly, here's my P, here is another P, and I can straight away see that it is an isosceles triangle, so that's going to be 45 degrees, which means argument of U equals 45 degrees. Now, I need to do the same thing for V, which is negative Q plus Qi. And once again, I'm going to do a quick little sketch. Negative Q is going to be somewhere here. Positive Q is somewhere here. And once again, it is an isosceles triangle, and the angle that is going around 90 plus 45, that's 135. So argument of V is 135 degrees. So if I want to put them together, argument of U over V is the same thing as saying argument of U minus argument of V, which is 45, take away 135, and it gives me negative 90 degrees. So grades wise, we are looking at merit for the negative 90. Yeah, if you do this method, it's only achieved or a merit. There's, no, frozen screen. Damn it. I gotta explain all of that again. That sucks. Such beautiful working too. Okay, we're gonna have to try and do that question again from frozen screen, frozen screen. Sucky moto, man. I wish there was like a little sound thing that actually tells me when the frozen screen is frozen. That's okay. Which question is this? Question 1D. Where are we frozen up to? U plus PI. Petra, I do have a tablet. It's an iPad that they give me. I just can't stream with, because I like that I can't connect that to my what do you call it? I can't connect it to my Windows machine at home. All right, give me a second, guys. I just gotta restart. That sucks, man. It was such a cool question that I was just kind of going with the flow. I gotta edit that out now. I'm gonna ramp. I have to speed up now because I know we've kind of been going for about an hour and 15. I have a, here we go, we're back in business. I have a lovely, lovely laptop. Well, the MacBook is just stunning, I have to say. That I have no issues with. But it's just because my home setup at the moment is with Windows, it's a bit more annoying. All right, here we go. There's where we were. We're back in business. Cool. So where we at? Where we at? P plus pi. Okay, so I'm going to draw the P plus pi first. So that's P there, and that's P. Yes, we are good to go. It's working again, which means the angle we're looking at is 45 degrees. So argument of U is 45 degrees. Then we've got V equals negative Q plus QI. That is negative Q is here, positive Q is there, which gives us an angle of 135 degrees. So argument of V is 135 degrees. And if we look at this formula here, we can say that argument of U over V equals 45 degrees minus 135, which gives us negative 90 degrees. So yeah, we pretty much got to get this answer right for a merit. You can get achieved if you were to go through this and kind of like rationalize and then kind of solve it, then you can get a merit. But there's nothing wrong in doing the method that I've shown here, which just gets you a merit straight away. .270 as the positive angle. Oh, right. I was like, what does it mean 270? Yeah, of course you could. Because it's just a 360. Yeah, 270 is fine, man. Like I wouldn't be stressing about it. Minus 90, 270, same angle. Any other question, guys? We gotta ramp it up now. We've got coming up to my question E. Good to move on? All right, folks, let's get to the final question, which is question 2E. Well, when I say final in this part anyway. Now, what you guys have got here is classic Cartesian plane question, all right? So all you got to do is, and I know that in Victor, you've been asking about the whole line thing. This is pretty much, this is what it comes down to, that whole line thing is we're looking at the modulus, all right? So the first step in this question that we're going to do is we're going to put down Z is X plus IY. All right, we're just going to put that down. That's anytime you're doing like a Cartesian equation question, locus question, you just put this straight up. Don't even worry about it. Just put X plus IY. And then what you got to do is get rid of the Z. So if you think about it, we've got a Z here, and we're going to replace it with X plus IY. So we got X plus IY plus I squared plus, what have we got here? Z minus I. So we've got X plus IY minus I squared equals 10. So because, well, where did it go? Because we know that modulus, like I'm just looking at the modulus, right? And I guess I need to be a bit more specific with this. This part right here, the modulus, I know that the modulus is square root of whatever the real part is. Real part in this case is x squared. The imaginary part is y plus 1 squared. All right, now I'm going to try and kind of explain how I got that real quickly. So the first thing I'm going to do is I'm going to put this as x plus y plus 1 I, and it's still a modulus squared plus x plus y minus 1 I squared equals to 10. Now, because it's modulus and then squared, I can forget about the square root because the square root squared is just, it's going to get rid of itself. But I'll show you guys anyway what it looks like. So this is going to look like this. Square root of x squared plus y plus 1 squared. That whole thing is the modulus, but we still got that squared to deal with, plus square root of x plus y minus 1, sorry, x squared plus y minus 1 squared. That whole is also getting squared, is equal to 10. Now, because square root and squared, they're next to each other, we can get rid of them. And what we're going to end up with is x squared plus y plus 1 squared plus x squared plus y minus 1 squared equals to 10. Now, as you guys can see, the only thing we really need to do here is pretty much just expand and simplify, and that's it. And once again, my computer screen is frozen. Or not. Nope, it's not frozen. That's good to know. Cool. So once we got this, we need to expand the y plus 1 squared and y minus 1 squared. So we're going to get x squared plus y squared plus 2y plus 1 plus x squared plus y squared minus 2y plus 1 equals to 10. So putting everything together, we're going to get 2x squared plus 2y squared plus 2 equals to 10. We've got 2x squared plus 2y squared equals 10 minus 2, which is 8. Get rid of the 2, as it's a common factor, equals 8. X squared plus y squared equals 8 over 2. And x squared plus y squared equals positive 4. So pretty much that's all that you need for this particular question. All right, so excellence wise, you're going to get the final line gets you an excellence. Correct expanded expression line 4. So it's 1, 2, 3, 4 gets you a merit. So merit is this line right here. Get up to there and you end up getting a merit. But I don't think there is no achieved for this question. So it is just a straightforward M or a E question. So Cartesian plane, like locus questions, always remember, put z equals x plus iy, get rid of the z, and then just expand and rearrange and bring things together, and you should be good to go for a nice and straightforward excellence there. Guys, any questions from you guys here? Yeah, this one is, compared to some of the previous questions I've seen before. Ooh, that last question is not fun. Cool, are we ready to move on, guys? I want to try and wrap this up by 10. I like Cartesian plane questions because they work out real nicely at the end. All right, guys, so on to question 3. What we've got here is nice achieved question. U, V in polar form. So all we've got to do is, what do we've got? We've got 12k cubed, because remember that we can rewrite this like this: 12k cubed over 2k cis of pi, take away pi over 3. All right, this is just some De Moivre's theorem that just have to keep in mind. Once you do that, it's just 12 over 2 is 6, k cubed over k is k squared, cis pi take away pi over 3 is 2 pi over 3. How did I get that real quickly? Well, I know that pi could be written as 3 pi over 3. 3 pi minus pi is just 2 pi, and then we're good to go. Grades-wise, achieved. Any questions, guys? Yeah, no worries, Stella. Catch you later. Move on. Yeah, it is pretty straightforward, isn't it? Okay, so going to question 3b. Once again, we are coming back to this z squared thing again, well, modulus. So we've got to actually work out what modulus of z is first. So modulus of z is going to be square root of 5 squared plus negative 1 squared, and then modulus of W is going to be square root of -2 squared plus 3 squared. So in this case, we've got square root of, what do we got? Square root of 25 plus 1, which is 26. And then on this side, we've got square root of 4. 4 plus 9 is 13. So as you guys can see, modulus of z squared, that's going to be square root of 26 squared equals to 2w squared, which is going to be 2 times square root of 13 squared. And you can kind of straight away see that this is going to work out real nicely. 26 is equal to 2 times 13. Yeah, so that's pretty much it. So you don't really need to do much apart from just kind of show that both of these things equal to each other. So 26 equal to 26, you're done. Ends up with an achieved for this question. No worries, Invicta. See you later, man. See you, JB. I think this was your question, Invicta. You kept asking about modulus and absolute value. Are we ready to move on, guys, to the next question? Cool. Just going to keep chipping away until some questions pop up. All right, so question 1C. What we've got here is one of these little proof questions again. All right, so we've got a plus bi conjugate. So if z equals a plus bi, then z conjugate is a minus bi. So we're just going to show that this is a real number, right? So we're going to go a plus bi multiplied by a minus bi over a plus bi plus a minus bi. So as you guys can see, all I've really done is just substituted z and conjugate of z, that's all. So in the numerator, what we've got is expand out the quadratic. So we've got a squared minus abi plus abi and minus b squared I squared divided by bi disappears. So we've got a plus a, which equals to 2a. In the numerator, these two things disappear. And we've got I squared is equal to -1. So we're going to get a squared plus b squared over 2a. And you can kind of say this, well, this is real. You don't really, there's no I. So this is a real number. And that's pretty much it. Correct solution with the statement indicating real part or imaginary part equals to 0 gets you merit. So you do need to kind of mention some sort of reason to get merit. Both numerator and denominator evaluated correctly. So just getting up to here is going to get you an achieve, but giving the reason is going to get you a merit. Cool, so that's basically it for question C. Oh, yep, thanks, rotation. Yep, sorry, that was a little mistake there. That should have been 2A. All right, moving on to question D. Possibly one of my favorite questions with question D is when we're doing complex roots. So with complex roots, I know I've done some couple of tutorials before where you just kind of, how do I say it? There's this algorithm, right? You basically take the complex number, convert it into polar form, and then you literally just add how many other angles that you need to go with. So let me show you guys what I mean by. So when we have z to the power of 4, we know that there's going to be 4 answers, and the difference between each of those 4 answers is 90 degrees. All right, so if you find one root, then you just got to add 90 degrees to all of them, and you're pretty much good to go. So the first thing is looking at first thing is looking at Z4, right? And putting it into a polar form. So I'm going to kind of draw this out here. Negative 16K8 is somewhere here. All right, that much I know, negative 16K8. Now the angle that it's going is going to be 180 degrees. So that is what I'm going to start with. So Z4 equals, now because it's modulus, it's going to be real numbers. So it's going to be 16K to the power of 8, cis 180 degrees. Now looking at my first root, I can say that Z is equal to 16K to the power of 8, cis 180 degrees to the power of a quarter. So Z is equal to 16K8 to the power of a quarter, cis 180 times a quarter. So from here, I can see that my first root, 16 to the power of a quarter is 2. K8 to the power of a quarter is just K squared. Cis 180 times a quarter is 45 degrees. So this is my first root. And because this is my first root, and I got to just add 90 degrees to all of them, I'm just going to do this. Just write this all down first. 2K squared cis of everything. 45 plus 90 is 135. 135 plus 90 is 225. 225 plus 90 is 315. Now you can actually write these answers in degrees. So I know some people actually end up working in pi and kind of gets a bit messy, but trust me, you can actually do this in degrees. I'm looking at the answer schedule right now. It does say accept equivalence in degrees. So grades wise, these 4 answers is going to get you a straightforward merit. Achieved is Z4 written correctly in polar form. So that's achieved here, or you could get achieved there as well for the first root. Or if you get all the angles correct, you could get an achieved as well. I would strongly recommend you guys to have a look at one of my tutorials from last year, I think, complex roots tutorial. It pretty much goes through this. I think I dedicated like one whole session on this. And it's pretty straightforward once you get the hang of it, because it is a nice little easy merit question to kind of keep in the back of your hand. Cool, that's basically it for this question, guys. Any questions from you guys that are sitting through this? Rotation, just have a look at the complex numbers 2020 playlist. Let me see if I can find it, man. Just give me a second. I'll find that video. Trust me, I pretty much spent like a whole complex number tutorials. Where is it? Just got to try and find it. Complex roots, 24th, 19. Okay. Yeah, no, just give me just drop me an email or something, Rotation, and I'll see if I can try and find that video. I know it's there somewhere with the polar form. It might have been like one of the Mathdemic series that I did. I know it's there somewhere, but it is worth a watch. Okay, can we actually go on to the last question, which is the final excellence question? Yeah, just drop me an email, Rotation, and I'll try and see if I can find that video. All right, guys, so we're going to the last question, which is a bit of a long one, so I do apologize. It will take a bit of time to kind of get through this question. It is a two-part question, so we kind of have to, mess around with it quite a bit. So to start off first, we've got two complex numbers, u and v. We're going to put down u is equal to a plus bi and v as c plus di, okay? Because they're two completely different complex numbers. So the first step that we've got to do is we've actually got to prove this part here first. That's the first thing that we've got to do. Once we prove that, then we've got to do u over v is purely imaginary. So I guess we're going to try and do one part at a time. So the first part I'm going to do is the modulus of u plus v. So modulus of u plus v is going to be a plus bi plus c plus di and the modulus of that. So if I look at it like this, I've got a plus c and then b plus di. And if I put this as a modulus, I'm going to get a plus c squared equals to, not equals, sorry, plus b plus d squared. All right, so that's the first kind of idea behind the modulus of u plus v. The next thing I'm going to do is u minus v. So doing u minus v, I'm going to do the same thing. I've got a plus bi minus c plus di, like this. And when I expand that little bracket out, I'm going to get a plus bi minus c minus di, and then collect all the real values, plus b minus di. And then modulus of this is going to be a minus c squared plus b minus d squared. Now it does say that both of these modulus are actually equal. And that means I could say that basically these two things are equal. Get rid of the square root symbol, and I've got a plus c squared plus b plus d squared is equal to a minus c squared plus b minus d squared. So that is what I have got so far. All right. Now I need to expand these little brackets and kind of like bring it down to like a nice little statement. So it's a whole lot of quadratic expansions, but that's what it is. So I got a plus c times a plus c. That's going to give me a squared plus 2ac plus c squared. B plus d squared is going to give me b squared plus 2bd plus d squared. And then on the right hand side, I've got a squared minus 2ac plus c squared plus b squared minus 2bd plus d squared. Hoping you're with me so far. Then we need to get rid of all the things that we don't really want to deal with. So a squared and a squared disappear, b squared disappears, d squared disappears. Yep, all of that gone. What we're left with is just 2ac plus 2bd equals negative 2ac minus 2bd. So what do we have next? We can rearrange them, which means we're going to get 2ac plus 2ac plus 2bd plus 2bd equals to 0. We've got 4ac plus 4bd equals to 0. Now we can get rid of the 4, and what we simply have is ac plus bd equals to 0. So this is pretty much that first part of the proof that we worked out. So we basically did this. If u plus v equals to this, then what we end up with is ac plus bd is equal to 0. Now we need to use this information to try and prove that u over v is purely imaginary. So we're going to do u over v here, which is a plus bi divided by c plus di. So the first thing we got to do is we've got to rationalize this denominator. So we're going to multiply it by c minus di, and the numerator also by c minus di. So when we do this, in the numerator, we've got a plus bi multiplied by c minus di. In the denominator, because it's a difference of two squares, I can rewrite this as c squared minus d squared I squared. Expand the numerator. A times c is ac minus ADI plus CBI minus BDI squared. Well, that's a whole lot to take on, but we're there. And then in the denominator, we've got c squared. I squared is equal to -1. So -1 times d squared is positive d squared. And so in the new, we've also got another I squared, which I forgot about, but that's okay. Minus ADI plus CBI, and then here I'm going to get rid of the I squared that's here, which becomes -1. -1 times -BD is positive BD over C squared plus D squared. Now, I can split this up into real and imaginary. So I've got AC plus BD over C squared plus D squared. And then I've got plus minus ADI plus CBI over C squared plus D squared. And as you guys can see, we actually showed that AC plus BD is equal to 0. And because it's equal to 0, we're going to get 0 plus negative AD plus CB, and that's with the I on the outside, over C squared plus D squared. And at this point, you can actually say, therefore, U over V is purely imaginary. That's pretty much what you need to do for this particular question. Actually, it didn't take that long as I thought. It was just that first part, that yellow part that I highlighted, that you've got to kind of come up to some sort of statement, like the statement here. Once you have the statement, then it's just learning when to substitute it to get rid of the real part. Again, these types of questions, it actually does work out quite nicely, these proof questions. It is something to keep in mind. Grades wise, we are looking at obviously final proof, which is excellence. Correctly simplified expression for U plus V and U minus V gets you a merit, which is somewhere here. And then correct expression for that gets you an achieve, line beginning with arrow. So you're looking at achieve just getting up to this part right here. Yeah, so this question, I think it just has like a lot of expanding, as you mentioned, rotation. It does have a lot of expanding and rearranging, but that is what complex numbers in algebra is. Cool, guys. That is it for this question here. Do you guys have any questions here online? Can't you go U equals A plus BI, V equals to C, A minus BI? Revish, no, definitely no. We cannot do that at all. The reason we can't do that is because what you've actually done there is U conjugate of U. So for example, if you put U is equal to A plus BI, V is a completely different number. Conjugate of U is A minus BI. At no point in this question do they say that V is a conjugate of U. So that's why you can't do A minus BI. Yeah, not a problem, rotation. But yeah, now if you guys don't have anything else, any feedback? When do you want to do differentiation? How do we find this session? Was it like, I know it was long, it was like an hour and 45, but like, any feedback would help moving forward. Or do you guys prefer like just, yeah, yeah, no worries. See you later. I think we're done rotation. That was the last question. Sweet. Yeah, it was pretty good for me because it's like it was nice kind of like doing the question and then just talking and then like I can just put it together later, so it's not a problem. I hope I recorded all the questions because that would suck if I didn't, which I'm sure I did. All right, team. In that case, I will leave you guys to it. I will upload this full edited video later on tonight. So it'll take a bit of time to kind of like put it all together. But apart from that, I will catch you guys next time. I think next time we'll do differentiation, pretty much same style. We'll get the paper ready and then we'll kind of sit through for a couple of hours, 2 hour marathon and just get it done and dusted. Thanks, guys. Have a good one, and I'll catch you guys next time.